Hello and welcome, Mr. Crofton here, coming at you with another geometry lesson. We're talking about two-column proofs here, so let's get started. Two-column proofs are ways to prove certain things. Generally, triangles are congruent, and then things based off of that. They're broken up into two columns. Statements on the left, usually numbered in order, and corresponding reasons that go with it, also numbered with the same corresponding numbers. Okay. Over here on the right, we see a figure's given to us, and we've got a given and a proof. So you always start with that given, you always end with the proof. So watch this magic. Look at that. Our first two statements are free. They are given to us, and even the reasons given to us. The reason why I know that S is the midpoint of AO and MA is parallel to ON is because it's given. So I like to say, hey, these are usually like, 6 to 8 point proofs. That's two of your points there, right? Just stating that and that it's given. Easy points, make sure you get them, all right? Now, you should mark it in case you didn't already. We already have the parallel part given to us, drawn in there. I also want to look at the fact, statement number 1 says S is a midpoint of AO. AO goes from here to here, and I know S is the midpoint. That means AS is congruent to SO. That is my third statement. And like I said, AS is congruent to SO. And the reason that I know that is because, well, I said it's the midpoint, and I know midpoint is halfway through a segment. So it's the definition of a midpoint. Okay. And pardon my bad handwriting, I'm doing my best here. Okay, on to the next thing. All right, now I want to look back at the fact that I've got parallel lines. So that's statement number 2, MA parallel to ON. All right, if those two lines are parallel, then I know, let's go green here, I know that I can kind of make alternate interior angles here. We see these a lot in geometry and in these proofs. So my statement is angle, let's call it MAS, that's an S. MAS is congruent to angle NOS. All right? And that reason is because, like I said, alternate interior angles. Super. Okay. All right, and I'll mark that as I do it. Boom. This is congruent to that. All right, let's look for something else. Now, I want to note that I could go two ways from here. I've got one side and one angle that's congruent. I need something else to prove, again, that my triangles are congruent. So I could either go with the vertical angle in the middle, or I could go with another pair of alternate interior. Let's go vertical, because why not? Angle OSN is congruent to angle A, angle ASN. And that reason there is because they're vertical angles. Okay, this angle congruent to that one. Now my whole goal is to prove the triangles are congruent, and guess what? I've got enough info. So statement number 6 is going to be triangle. I want to do exactly that, right? Triangle SAM is congruent to triangle SON. My reason being, look at what shortcut I used. An angle, then a side, then another angle. So ASA congruence. All right. We got a proof down. And notice, again, two big things. This are given, easy. This is what I want to prove. So half of those statements there were actually already written on the page before I started. Okay, let's try another one. All right, now, again, given, look at these. Boom. Take them, put them right over there. Statement 1 says those two sides are congruent. I'm going to mark it. RA congruent to ST. Statement number 2 says RS congruent to AT. Mark it. Those are both given to me. Okay. Statement 3, a lot of you might have your eyes drawn to this middle segment that is called, there's a shared segment. So I'm going to say SA is congruent to SA. Well, that's pretty obvious. That reason is a property called the reflexive property. That something is equal to itself. It's a pretty self-explanatory one, right? Okay, now, my goal is to prove eventually this, but I can't jump to that. But once I say, and I can say, that triangle, let's name it RAS, is congruent to triangle RAS and TSA by, let's see, reason 4, by side, side, side. Since I said that those triangles are congruent, and I do have good justification for that, my next statement can be, all right, if the two triangles are congruent to each other, then I know that angle R is congruent to angle T because CPCTC, which stands for corresponding parts of congruent triangles are congruent, which is basically saying, hey, if the triangles are congruent, I know every part's congruent. So that means my angles, that is R and T, are going to be equal because the corresponding parts. If two things are exactly the same, then every part of them is exactly the same. So the angles are. All right? In case these videos don't help you too much, I found this great new hotline that you can call. So any issues, pause the video and you can just write down this number. Just give it a call sometime and they'll be able to help you out with anything. They can help you with any test, quiz, preparation, anything like that. If that doesn't work, another option, if you really have these math problems and you got to figure it out on your own, my suggestion, put on your thinking cap. Oh, your thinking cap? Oh, that's hilarious. All right, last one, last proof we're going to do here. We want to prove that KR bisects angle PKF. Okay, but again, it's good to have that end step in mind, but always be starting off with your givens. Let's go read this. Statement 1, statement 2, reason 1, reason 2, all given. So we're literally just copying that down gets you those points. From there, you should mark it up. Okay, PR and FR, I see that. Okay, got those as being congruent. Next thing I say is KR bisects PRF. KR is this line right here. Angle PRF, I can trace it, goes from here to here to here. So I'm saying that angle there is being bisected. And because we're all awesome geometry students and we know what bisect means, it's going to mean that this half equals that half. All right? But I didn't state that yet. So that's what I need to state here. 3 says angle. Let's name it. P, was that the R? Yeah. PRK is congruent to angle FRK. Okay? I'm just stating what that meant to say that two things are bisected. And my reason for that is because, well, if you're telling me something's bisecting an angle, I knew the two halves are equal because it's what bisect means. So it's going to be definition of bisect. Awesome. Okay. So I got a lot done now. My goal, again, is to prove that KR bisects the other angle. So that's this side out here. I want to prove that that and that are equal. But I can't go ahead and say that. I got to prove they got congruent triangles first. And I see, look at that shared side in the middle is going to give me something. So I'm going to say, let's see, it's RK is congruent to RK. And this, going back to my other one, is the reflexive property. Super. Okay. All right. I've got enough to prove two triangles are congruent, so I'm going to go ahead and do it. Sorry, that bothered me. Statement 5. Triangle P, R, K, congruent to triangle F, R, K. My reasoning for that is the side, angle, side congruence shortcut. Because I got a side, an angle, and another side. All right. Now, a lot of people might say, okay, can't I just go to KR bisects PKF now? No, not just yet, right? Like I said before, my goal is to prove that these two angles here are being cut in half, Well, if triangles are congruent, then yeah, I can say that those two angles are equal. So, angle PKR is congruent to angle, let's see, PKR and FKR. And that is by, always after that triangle congruent shortcut, you're going to see CPCTC, CPCTC, right? Because once you prove triangles are congruent, that means you can say that their parts are congruent. Last part, I prove that those two halves are equal. That means, hey, if those two halves are equal, then I know that KR bisects angle PKF. My reason for that is, like I said, I know that if something's cut in half, it's being bisected. So that is the definition of bisect. All right, guys, there's your video for you. There's a couple examples. Hopefully this helped you out. Keep on rocking. I'll see you in class.